Alright, in this video we are going to look at how to use Hess's law to solve a problem. So this problem says calculate the energy change in the following reaction. And it gives us this target reaction right here. And then it gives us two other reactions with known enthalpy change values. And so that's how you'll know it's a Hess's law problem, when you're given a target reaction and then you're given two or more reactions, sometimes with known delta H values. And so what we need to do is we need to rearrange these reactions so we can sum them up and get our target reaction. So what I like to start out by doing is looking for things that only appear once out of our two equations that we are given. And so the first thing I notice is that SO3 only appears once out of both reaction A and reaction B. The only place it appears is right here. So I need to make sure that my SO3 ends up with the correct number and on the correct side of the reaction just by manipulating reaction B. So I'm going to start there. We're going to manipulate reaction B first. So I'm going to put reaction B here, and then I'm going to rearrange it so it looks more like my target equation up here. So reaction B has two SO3s on the reactant side, but in my target reaction, I want those SO3s to be on the product side. I have the correct number, but it's not on the correct side of the equation. So I'm going to flip reaction B around. So I'm going to put my reactants, my original products become my reactants, so 2SO2 gas plus O2 gas, and then my original reactant will become my product. Yields me the 2SO3s, and that's a gas. And because I flipped my reaction around, I also need to flip my delta H value. And when I say flip, I mean change the sign of my delta H value. So I'm going to move this over just a little bit to give us some room. My new delta H value, I'm going to change the sign here. So instead of it being negative 297, it's now going to be positive 297 kilojoules. Okay, so there's my first equation. And what I like to do is I like to box in the things that I need to keep. So I want to keep my two SO3s, so I'm going to box that in right there so I know that I need to keep that for my target reaction. Okay, so then I'm looking at reaction A. That's the only thing I have left to work with, so I know I'm going to make some manipulation to reaction A. And the thing that I notice about reaction A is that this sulfur, the solid sulfur, is on the correct side. It matches my target equation, but there's not the right number of sulfurs. And so looking just at that sulfur, it tells me that I'm probably going to have to multiply my reaction by 2 to get to my target equation. So I'm thinking that, but I'm also kind of looking at what's going to cancel. And when you're doing Hess's law problems, it's important to look at one thing at a time and try it out, but then to also at the end make sure things cancel. So we're going to go ahead and try out multiplying reaction A by 2, and then we'll make sure that our things that we don't want end up canceling out. So let's try that. So we're going to multiply reaction A by 2. So I'm going to actually put my manipulations next. So I flipped to reaction B. Now I'm going to multiply reaction A by 2. So I end up with 2 sulfurs, solid, plus 2 O2s, gives me, and I'm actually going to move this over a little bit. I like to line up my arrows pretty well. Gives me 2 SO2s. Yes. Okay. So let's just make sure before we do our manipulation to our delta H value, let's make sure that things are going to add up properly in the end. So I wanted to keep these 2 sulfurs, and there's nothing on the product side to cancel it out, so those will stay. But now I need to look at whether or not this SO2 will cancel out, because I don't want these SO2s in my target equation. They're nowhere in there. But lucky for me, I have 2 SO2s on the reactant side, and then I have 2 SO2s on the product side. So those are going to cancel out. I have one on the reactant side, one on the product side, so those cancel out. And then all that's left is these O2s, but because they're both on the reactant side, rather than canceling out, they're going to add together. So I can combine this one O2 with these two O2s, which will give me a total of 3 O2s in my final reaction. So let's write out the equation that we wound up with. So when we add these equations together, we cancel things out, we are left with, on the reactant side, our 2 sulfurs, solid. So we did that one. We're left with 1 plus 2, so 3 O2s. So that's on the reactant side. And then the product side, all that's left is these 2 SO3s. So let's double check to make sure this matches our target equation. 2 sulfurs, perfect, plus 3 O2s gives us 2 SO3s. That does match, so we know that we did this right. So now all I have left is to manipulate this second delta H value. I multiplied the equation by 2, so I also need to multiply the delta H of reaction A by 2. So negative 297 times 2 kilojoules. Going off the screen a little bit there, bring it back a little bit. So let me get my calculator, my trusty calculator. So let's clear that out. Negative 297 times 2 gives me negative 594 kilojoules. Alright. And since I added my equations together, Hess's law says that I can also add my delta H values together to get my delta H of my target equation. So I'm going to do the delta H of my target reaction equals positive 297 kilojoules plus a negative 594 kilojoules. Okay, and when I do this in my calculator, 297 plus negative would be minus 594. I get negative 297 kilojoules. And that is my final answer. Move that up just a little bit so you can see that final answer, negative 297 kilojoules.